kayang i-sustain yun ng ng SR-71. Okay? Which I believe is still used now by US. Okay? But of course, they are really now uh, relying on satellites. Okay? So that is your area. No? Satellites na ngayon. Wala nang ganun. Wala nang U2. Wala nang spy plane na tinatawag. Puro satellite na ngayon. Okay? So, kayang uh, kayang i-monitor lahat yung nasa baba, no? Then of course, that is the technology. Okay? Now, yung problema lang kapag maulap, okay? Pag maulap, syempre hindi ka makikita. And of course, kung dense yung area, no? Let's say vegetated siya, no? Ang daming puno. But of course, alam naman natin ngayon, naubos na rin yung puno. No? Now, of course, doon naman, siyempre hindi ka kita, but they can use thermal imaging. No? So still, you can be monitored, no? Even if you are under. Okay. So we have here, we run here. So we have this already, viscosity, and so on. I think, yeah, we're until here, up to here. Okay, we have now the laminar and turbulent flow. So we have this, and you shear, okay. Then of course, we have the laminar and turbulent flow. So this is the moment when the air will depart from the surface because there is viscosity, no? If the air will pass through the surface, this is the plate, no? Mag-stick yan rito, but still, no? Along the way, it will disengage, no? There will be a separation, okay? And once na nag-separate yan, hindi naman yan pupunta anywhere, no? It will go back. Babalik yan, no? Pag tama niyan, babalik pa rin yan. Okay, babalik. Okay? But that balik, no, will of course produce a up and down, no? Up and down flow of air. Okay? And that is what you call the turbulent flow. Okay, so we have here a point of transition where this transition is do not have any activities, no? Walang activities to. Kasi pwede natin sabihin vacuum, but parang siya awkward na gamitin, no? That is where there will be no activities, no? So ibig sabihin, because the air particles jump, this is black, no? So if there is any dust, no, the dust will remain here. Okay? Kapag stationary plate, no? But of course, if the plate is moving opposite directions of the air, no, that is a continuous, no? Continuous yan. Pagka in-stop mo yan, then the air is moving, no, at the top, and the plate is not moving. So there will be a build-up if there is a dust, no, here, because the dust will not be of course, it will not be touched by the moving air up and down. Okay, so this is a turbulent flow. Okay, so this turbulent flow, no, will produce a downward force dito sa portion na yan. It will produce a downward force. Okay, so this will lose. If there is producing lift, no, this will lose lift because of the turbulent flow. This will have a lift, no, because that is a laminar flow, or the air is sticking to the surface of the object. Okay? Now, kaya kapag tinawag yung clouds, no, di ba, pagpapasok, sasabihin gano'n ng piloto na fasten your seatbelt because we are passing through a turbulence, no? A turbulent area. So, ibig sabihin, that is a cloud wherein there is a lot of air moving. Now, bakit? Ganito yan. You know, uh, ito, later on na wala na tayong gagawin niya, puro ano na lang, ito, no? So, these are the clouds, okay? Dumami, okay? So, we have here a moving airstream, okay? And this is the aircraft. So, ito ang pag-usapan natin portion na to, turbulence. So, assuming the airplane is flying here, then there is a wind, no? And the wind, pagka tumama yan niya, hindi naman yan lulusot, okay? We'll go there. Some will go there, no? And of course, yung iba dito. Sana. Okay? And of course, this will go there. Okay? Tatama yan rito. And of course, some will go there. And it will produce turbulence, no? Because this is solid, di ba? Solid lang, no? So, itong cloud, so there is possibility na umikot yan rin. So, pag umikot yan, what will happen now is that this airplane will be affected and this will drop. Maglulos ng lip yan. Okay? So, the same yan with mountains, no? So, this is a high mountain. Okay? There is another one here. And there is another one here. So, ito yung hangin yan. Okay? And from here, aakit yan doon. Okay, aakit yan riyan. Then gaganon. So, this portion is, of course, turbulent area. Okay? Now, you know, last time, di ba, meron sa bandang Quezon, no, na bumagsak na chopper kasi dito siya pumesto sa gitna na to. And this is a new aircraft, no? So, yung, ano yun, actually, PNP aircraft yun, and the pilot is my student before. Student. Nakadalawa na nga yun eh. Isa rin bandang Quezon at isa sa Kalinga. So, pareho chopper bagsak parehas. So, dito siya. So, hindi niya masyadong consider na there are turbulent flow which is hitting the chopper. So, once na nag-turbulent flow yan, there is a tendency na yung blade mismo may hirapang kumuha ng lift. Bakit? Itong pakpak na to, yung pakpak na to, ito yung pakpak ng yung wing niya. Okay? So, yung wing niya, merong flow yan. Okay? Which will be discussed later on. May flow yan rito, and this is generate lift, no? What if this is the air that is passing is turbulent? So, the tendency is this wing will not produce a lift. Now, for a chopper, sa chopper, itong yung rotor blade niya, the same cross section, ganito rin siya, okay? So that is why we call that a rotary wing. Okay? Rotary wing. Yung wing na to ng aircraft, yan, is the wing. Pagka chopper siya, that is a rotary wing. Okay? Umikot. So it lose lift. Okay? So that is a simple diversion, no? Nag-divert siya ng sa performance siya. Okay? So the chopper drops, no, from its position. Okay? So, we have here the Reynolds number. So, last time we talked about the density, and of course, we know about the kinematic viscosity. So, dito ngayon makikita mo, ito yan. Okay? So, Reynolds number is equals to, actually, Reynolds number do not have a unit, no? So, that is velocity, length, over kinematic viscosity. Because kinematic viscosity is dynamic viscosity over density, right? Ay, ito na pala. Yan. So, ibig sabihin, Reynolds number is directly proportional to velocity and the L. Yung L na yun, that is length. Actually, this is also equivalent to B times C over kinematic viscosity. Okay? Ano yung length na yan? Ito yan. Balik tayo rito para hindi na ako mag-drawing. Ito, from here to there, that is now your length, or gawin natin na chord. This is your chord. Ito, that is the length. No? So, ito yan. Okay? So, ibig sabihin, if you increase the velocity, the Reynolds number will increase. If you increase the kinematic viscosity, the Reynolds number will drop. No, it will of course it will go down. If you will increase the length, the Reynolds number also increases. And of course, we have a Reynolds number. At low Reynolds number, the flow in the boundary layer tends to be laminar. No? So, boundary layer. Okay, boundary layer, siyempre ito yan. This is the layer. No? Boundary layer. Turbulent, laminar, and turbulent boundary layer. Ito yung boundary layer. Yan. Yung tinatakbo ng hangin. Okay? So, however, above certain transition Reynolds number, approximately ito yan, 3.5 times 10 to the 5th, okay, up to 10 to the 6th, the flow becomes turbulent. So that is turbulent. So this is very important to, no, especially if you will design an airplane. So ito ang unang dinedetermine ng designer, what is the Reynolds number. Actually, ikaw magbibigay niyan. So, magdi-design ka ng aircraft na Reynolds number ito. So, everything will follow. What is now the maximum velocity, what now the length of the aircraft, and so on and so forth. Where it will fly, and so on and so forth. So, ibig sabihin, Reynolds number, hindi mo yung kukumpitin doon sa given ng aircraft. Ikaw magbibigay na Reynolds number. And Reynolds number depends on the type of airplane that you will make, no? So let's continue, no? The flow becomes turbulent, no? In a laminar boundary layer, kaya pagka tumaas dito, magiging siya, turbulent, no? In a laminar boundary layer, the air particles follow paths parallel to the plate. So, while in turbulent boundary layer, there is a lot of vertical and that is up and down exchange of air particles. So we have a example, no? An object is moving at a density altitude of 15,000 feet. So ito, last time, 15,000 feet pa rin. So makikita mo, we have now negative 39 degrees Fahrenheit. So nakita mo, negative 39 degrees Fahrenheit. Let's check, no? So if H is equals to 15,000 feet, 15,000. Okay? So, check first the temperature. Okay? So, ito yan. Pero nakuha na natin ito before kasi 15,000 Notorious yan Nakita na natin yan. Piece of O minus lambda H. Di ba? And we found out that the temperature here is of course 519 minus 0.00 3566 times, siyempre, 15,000. Na-solve na natin to. If you're taking notes, may value na yan. No? Nakuha na natin yan. Okay, and what is now the temperature? Temperature at, ito pala, at temperature at T is equals to negative 39 degrees Fahrenheit. And what is this in minus 460? Ay, plus 460. So we have that is in radian, no? So we have 460 minus 39 equals. So 421 degrees Fahrenheit. 421 degrees Fahrenheit. So ilan ito? So during our computation last time, this is equivalent to 465.51. 465, we just recalling it. 465.51. Na ibinibigay niya ang layo, 425. Tapos yan. And this is also equivalent to 5.5 degrees Fahrenheit. Okay, so ang layo, di ba? So, dapat yung 15,000 feet, 5.5. Pero yung binibigay niya sa OAT niya, OAT, tandaan niya, that is outside air temperature is negative 39. So, ibig sabihin, this object is not flying at a standard altitude. Okay? So, after that, we will get now the pressure, no? So the pressure now, gagamitin mo to P over P sub O is equals to T over T sub O. Yeah. T over T sub O. So ganito yung ginawa natin last time, right? So nire-review na rin natin 5.26 to. Okay? So, itong temperature na to, gagamitin mo rito is, of course, yung temperature sa 15,000 feet. So, 465. Okay, ito. Ito ngayon, isulat na natin na. P, siyempre, that is 2116.8. You must be taking notes para ito ang lalagyan mo rin yung 465.1. So 465.1 based on 15,000, 465.1. 0.5 tala, sorry, over 519. 519 raised to 5.26. Then after getting this, you will get now the pressure. Pagka nakuha mo sa pressure, yan ngayon yung pressure ng 15,000 feet. Okay, yung sagot rito is PSF, pounds per square foot. Then, of course, we have now to get your density. So, density is P over GRT. GRT. So, this is the ideal density, no? Ideal gas, no? So sa ideal gas, gagamitin mong temperature yan, yung given, ito. Okay, so papasok yan dito, ito gagamitin mo yan. Okay, so this is now your negative up, 491 degrees Fahrenheit. So this is the actual atmosphere na dinadaanan ng aircraft. Okay. And it is flying at a non-standard atmosphere. Okay, atmosphere niya is negative 39, so ang layo, di ba? So, pagka nakuha mo itong density na yan, itong lang i-apply mo. So, what will now be the dynamic viscosity? Dynamic viscosity is, okay, 340.8 plus 0.548. Then, ano nga yung temperature yung gagamitin mo? Siyempre, gagamitin mo rin actual. Kasi actual na tungtukan natin. So, ito, negative 39 degrees Fahrenheit. Okay, we have to times 10 to the negative 9. To the negative 9. So, yung sagot rito, slug. Okay, slug feet second. So, that is slug feet second. Then afterwards, kunin mo na yung kinematic viscosity. Kinematic viscosity is dynamic over rho. So yung dynamic mo ito. Ito yung density natin. So kita nyo yung unang-una, kung yung 15,000, i-justify nyo kung ano yung temperature sa 15,000 is 465.5, no? So ang layo kasi dito 421. So i-solve the standard pressure at 15,000 feet. So nakuha na natin. Then kunin mo yung ideal gas law, substitute mo rito itong value na to. Pero gagamitin mo yung temperature nung actual, which is negative 39, ano to, 491 degrees Fahrenheit. Lipat ka sa dynamic viscosity, so gagamitin mo rito yung negative 39, which is the actual, no? Actual scenario na nililiparan niya. Okay, so you have now your density, then you can get now your kinematic viscosity. Okay, so after kinematic viscosity, you will now solve your Reynolds number. Okay, so Reynolds number is equals to rho VL over nu. Rho VL over nu. So, yung L mo dito is 6 feet. Yan. And the equivalent airspeed is 200 knots. So, we have conversion dito. Ito, 1.68781 feet per second per knots, no? So, solve mo yung Reynolds number. Okay? So, you can get now your Reynolds number, dimensionless yan. That is your Reynolds number. So, try to compute also, no? So, hindi pa pwedeng panunuorin mo lang yan. Okay, you compute also so that you can, other than what I'm saying, makikita mo na what is happening, kung bumababa siya o tumataas siya or what, no? But, of course, basta Reynolds number, if you increase the velocity, it increases. If you increase the length, it increases. Okay? And it is directly proportional to the velocity and length, but inversely proportional to kinematic viscosity. Now, what happened with the kinematic viscosity as you go higher? Yun, di ba last time na-compute na natin? Diba? What happened with the kinematic viscosity? So, the dynamic viscosity is becoming lesser as you go higher, right? And what is the density? It's go higher also. So if we divide, what happened? Oh, is it the density which is going down fast, or is it the dynamic viscosity which is going down fast? But of course, you have to divide it. Last time we identified it already, what happened with kinematic viscosity, what happens with dynamic viscosity as you increase your altitude. And this is something that will affect the aircraft. Okay? So that is why we have to compute for the unknown, no? Especially kapag non-standard. No? That is why, as I have said, laging chinecheck yung outside air temperature. Malay mo ba kung ano ka, gaano ka, gaano yung temperature sa outside, di ba? Hindi mo masabi yan. O, baka sa uh, flight manual mo, kasi sa flight manual, naka ano yun eh, naka-tabulate siya, may table. Nakikita mo kung ano yung temperature sa labas, alam mo yung pressure na sa labas, alam mo yung density sa labas. Okay? And this will affect the performance of the aircraft. Atmosphere pa lang yan. Ha? Wala pa yung performance mismo niya. Okay? Hindi pa pinag-usapan yung performance natin ng aircraft. Performance pa lang yan, affected performance due to the atmosphere. Okay? So, tandaan nyo na. Then, calculate for the Reynolds number of a wing having a chord of 4 feet. Okay? So, ito yung wing. Okay? We try to solve. Ito, solve nyo na kanila. Okay? So, kapag non-standard, no? Pagka non-standard, unang-una, paano natin sir nalaman na 15,000 feet? Tumingin ka sa altimeter mo, naroon yung 15,000. Okay? O paano mo nalaman yung outside air temperature? Tignan mo dito. Dito sa Cessna, dito nakalagay eh. Outside air temperature, makikita mo. Kapag tinignan mo sa sa manual, magkaiba, no? Hindi siya tumama na dapat yung temperature mo at 15,000 feet is 465.51. So, hindi ka nasa standard atmosphere. So, meaning, your Reynolds number will be affected by the kinematic viscosity. The change in kinematic viscosity and of course the density is different. Okay? So, just to observe lang yung Kasi take note dito mahalaga sa atin yung ito yung sinasabi ko palagi sa aviation kasi. Mahalaga sa atin yung yung instinct, no? Instinct or what you call the sinasabi ko situational awareness. Kasi pagka nasa task ka, seconds lang para mag-decide. Hindi ka tulad sa sa ibang engineering, di ba? Sa engineering, pagka nag-collapse yung isang structure, di ba, it will take time para gawin. It will take time, no? Una-una, kunyari, lumindol, huwag naman sana. Siyempre, lahat dito sa building, aalis, no? Bababa. Then, pagka, kunyari, may crack, so, hindi muna yan, i-check pa yan ng structural engineer, aabot pa yan ng 1 week or months, no? Bago siya maglabas ng Sa aircraft, pagka nasa taas yan, tapos nagkaroon ng problema, hindi mo na pababain yung mga pasero para ayusin mo. No. One time ka lang, no? One time. Mabilis ka dapat mag-isip. Yung mga ganito, dapat malaman mo na agad, no? Mabilis ka mag-decide. Okay? Kaya sabi ko sa kanila, sometimes you must also study the application or the effect of the that's why analysis, no? The effect of the equation, no? Hindi mo lang solving yan, hindi mo lang, ano yung saan siya directly proportional, saan siya inversely proportional. Okay? So, yan yung importante sa atin, no? Wala sa atin bukas eh. Hindi mo pwede pagpabukas yan, no? Ngayon mismo, ngayon ka magdi-decide. So, sasabihin mo, magkakalculate ka pa. No. Dapat alam mo na kung bumababa siya o umaakyat. Parang instinct lang, di ba? So, that is us, no? So, you have here your 100 feet per second. Sabi, standard sea level. So, wala tayong problema. So if the same wing will fly at 5,000 feet, compute the Reynolds number. So lumipad siya, okay? Then of course, if this plane will fly at 5,000 feet, compute for the Reynolds number. Okay? So, pagka standard sea level siya, siyempre yung density nito is standard, 0.002378. Kukunin mo rito yung ano, okay, corso. Yan. Density standard, okay? Then, of course, dito sa ano, kukunin mo yung density sa 5,000 feet. Okay? Sa 5,000 feet, of course, tingnan mo kung ano yung sa 5,000 at saka yung sa sea level. Okay, what happened, no? So, what happened with the uh, Reynolds number at it goes at a high altitude. So take note that the Reynolds number is directly proportional to density, right? Rho VL over mu. Assuming that the aircraft is flying at the same speed, no? 100. So makita mo directly proportional, lumaglag na yung density, di ba? But what happened with the dynamic viscosity? The temperature will drop. So dynamic viscosity will, of course, drop also. But kinematic viscosity is dynamic over density. So you compute. So what happened with the Reynolds number from sea level packet? Okay. Then at critical Reynolds number 4, okay, of 5.55 times 10 to the fifth, calculate their speed, feet per second, where a wing of 4 feet chord should fly. Assume a standard atmosphere. Okay? So dito naman, given na yung Reynolds number, ito, given yung standard atmosphere, so 0.00237 to, velocity niya is unknown. So meron tayong length na 4. So what is now the velocity? So equate mo lang ito. So that is your Reynolds number. So kaya makikita mo, all wing, it has a all wing or airfoil that was designed, no, has its own Reynolds number. Now, if you want the airplane to fly much higher, you will choose much higher Reynolds number. Okay? Eh sasabihin mo, sir, di ba pagka higher yung kapag high Reynolds number susceptible sa turbulence. Pag nasa taas ka na, wala na yan yung turbulence. So, hindi masyadong affected because kalmado. So, kalmado yung hangin sa ibabaw. Especially kung 36,000 feet ka na, 40,000 feet. Okay? So, yun yung yun yung twist doon, no? Now, dito sa baba, pwede siya masubject sa turbulence. Pero meron kang tinatawag na control surfaces. Yung control surfaces, ginagamit mo yun para ma-overcome niya yung possible na turbulence na mangyari. Sa aircraft yun. Ano ngayon sa tao, sa loob? Eh, siyempre, seatbelt mo yung sarili mo, di ba? Seatbelt mo kasi babagsak ang aeroplano yan. I mean, maglulus ng lift. Babagsak. So, we have now continuity equations, no? Streamline is a curve along with a tangent at any point on the curve always coincide with the flow velocity vector. So, tangent is of course more on parallel, diba? So, a stream tube is a group of streamlines adjacent to its other. No? It is evident that the flow velocity okay, normal to the exterior surfaces, no? So that is stream tube. Actually, di sa taas, sa pinakamataas na altitude, no, at 36,000 feet, from east to west, may tumatakbo rin, may umaagos rin, na air, no, which is what you call stream, no? Airstream. So airstream na yan, kunyari, from point here to point there, inaakit yan para mabilis yung aeroplano, para mabilis yan. No? Kasi tinutulak siya yun tinutulak siya ng hangin. Okay? So pag pabalik ka, huwag ka daraan ro kasi malakas yung hangin yan. Dito ka sa ilalim or dito ka sa ibabaw. That is what you call airstream. May airstream yan. Kung pupunta ka sa ilalim ng dagat naman, no, meron rin yung water stream. There is a tinatawag nila river, no, parang may river na kalmado dito, pero sa ilalim, mabilis yung agos. Okay, so halos parehas, di ba? Kaya lang dito, high pressure. Dito, low pressure. Okay? So, yun. Then, this is the stream tube. Okay? So, kinuha sa hangin, nilagyan niya, ito, inimagine lang na may stream tube sa hangin. No? So, in stream tube natin, we consider that that is a tube, no? Increasing in diameter. Okay? So, we have here area 1 and area 2. And of course, we have density 1 and density 2. And we have density 2 and velocity 2. Okay? So, yan. This is your section 1 and section 2. Okay? From point to point. Now, your mass, of course, we have a volume rate, we have density, we have cross-section, and we have the velocity. No? Accordingly, the equation is given by the mass is equals to density, area, velocity. Okay? Mass is equivalent to rho AB. So sabi, mass 1 is equals to mass 2. Or this is mass 2, sorry. Or this is equivalent to constant. So the mass will always be the same kahit saang portion dito. That is the mass, okay? Kahit saang portion siya rin. So that is why, sabi, rho A V is equals to constant. And this is equivalent to mass. Okay? Ay, sorry. Yan. Hindi over mass ba? Okay, rho AB is equals to mass. Okay? So, yan. Then, afterwards, no? So, ito na siya. Constant, no? Sabi constant. Fluid flowing at density that is incompressible. Kapag yung density, kapag incompressible flow yan, so ibig sabihin, pagka compressible yan, tuloy-tuloy yung agos niyan. Ito, from here. Pag yan incompressible, meaning, ito lang siya, hindi siya nagkakaroon ng compression. Ha? So, nag-flow lang siya, ibig sabihin, yung density rito is equivalent to constant. Whatever density passing through here will be the same density passing to this point. Okay? The same density. So, density 1, let's say this is 0.1 and 0.2. Density 1 is the same density 2. That is for incompressible flow. So, since incompressible flow yan, that the density is moving the same, no? Sa density dito, so we can say that density 1, rho V1, A1 is equals to constant. No? So, magiging rho 1, A2, B2. So, since the density is constant because incompressible siya, no, mabagal lang siya, so cancel yung rho 1. So, matitira rito is A1 okay, B1 is equals to A2 B2. And this is what you call rate flow. Yan yung rate flow. Yan yan, no? Volume rate flow. And area 1, A, B is equals to rate flow. So, ibig sabihin, the rate flow at this point, up to that point is the same. That is the rate flow. Pareho siya. Hindi siya nagbabago. That is the rate flow. Okay? Then, of course, kung cross-section niya, siyempre, circular, ito yan, pi d squared over 4 or pi r squared. And r is the ratios at section. Okay? So, constant yung Q, no? Constant yung Q. So, ibig sabihin, kapag mabagal siya, the mass is moving constant from here to there. And your density is equivalent to rho A1B1. Okay? Kapag yung density is constant, dito at saka dito, kasi ang bagal niya, kakakansilin mo yung density kasi siya pa rin yung dumaan roon, matitira yung A1B1. And this one is a formula for your rate flow. So meaning, for mass flow, if the density is constant, you will have your rate flow. Okay? So ito yan. So what is now your compressible? So ito, yung flow niya, ito lang flow. Yan yung nag-flow lang, dire-diretso. Okay? What about if compressible? Ito ngayon yung compressible. Pagka compressible siya, the tendency is that there will be a projection of shock wave. Okay? Assuming, ganito yan, diretso, yan. Dito tayo. Kanina kasi palaki. Ito paliit. Okay? Papasok siya riyan. Ito ang bilis, di ba? So what will you expect here? There is a choking point, no? And this will produce a shock wave. Okay? This shock wave, kung titignan mo, ito yan, no? Ito yan ay, ito lahat ng particles rito, no, from there to there, okay? Tutulak yan, so what will happen now, ito na siya. So this three will become one, okay? Then pagka bumalis pa yan, baliktad kasi drawing, kabila eh. Okay, it will become a shock wave. Okay. So pag ito, this is what you call the normal shock wave. And of course, kaya compressible yan kasi kino-compress niya yung layer of air. So kasi yan, kunyari, pag andar ko ito, pag start ko, yung sound tumakbo na, di ba? Tumakbo na lahat. Eh, binilisan ko. So habang umaandar yung sound niya, hinahabol niya, okay? Then nagpang-abot na sila rito. So that is compressible flow. Okay? And critical is that when the airspeed of the aircraft reaches the speed of sound. So last time we have talked speed of sound. Magpang-abot yan, yan ang tinatawag natin na critical Mach number. Bakit? Kasi itong shockwave niyan, pupunta yan sa katawan mismo ng aircraft. And that shockwave will produce vibration. Magbabibrate yung aircraft. Okay? Kasi naroon mismo sa kanya yung shock wave. Okay? So what happen is to reduce airspeed or increase airspeed. Kung kaya mo pang i-increase, so i-increase mo. Don't stay there, no? Kasi masisira yung structure ng aeroplano. Okay? Now, as I've said before, yung commercial airplane, yung mga passenger na sinasakyan natin, lumilipad yan at Mach 0.85 maximum. Yan yung top speed niya, Mach 0.85. Now, yung mga Airbus, Boeing, yan. Long haul flight, no? 0.85. Tanong, sir, paano yan kung lumampas siya ng 0.85? Siyempre, tatama siya ng Mach number, pero dapat i-monitor yan ng piloto. Kasi kung 0.85 yan, meron kang airstream sa likod na 0.15, so Mach 1 yan, magbabibrate yung airplane. Mararamdaman niya magkakaroon ng vibration. So that is why from time to time, minomonitor yung airspeed. Diba? Kasi sa mga palabas natin, oh, what is our airspeed? Diba? Diba? Hindi yan. So, minomonitor yan. Tanong, sir, minomonitor lang ba pagka mabilis? I-monitor mo rin pag mabagal. Ha? Kasi baka nung lumilipad ka, yung reading mo riyan is uh, isabi natin na 300, okay? Pero meron kang 50 pa harap rito na hangin, no? So, kung 300 yan, tapos may 50 rito, so lumilipad ka lang ng 250. Now, kung 250, makikita mo ba rin? Hindi, 300 pa rin ang makikita mo. 300 pa rin. Pero actually, your actual position and your actual movement is only 250 minus 50 na. Okay? Now, tatanaw, anong yun? Anong effect yun? Assuming na masyado ka mabagal, you might hit your stalling speed. And that stalling speed will produce the airplane to drop. Papagsak siya, mawawala siya ng D. Okay? So, ang dami, di ba? These are all the effect, no, of the atmosphere. And now we are talking about the effect of the movement of the aircraft through the atmosphere. Okay? So, yun yan. So, you know now the incompressible at saka compressible flow. Okay? So, this is now the parameters under compressible flow. Now, pagka compressible flow ngayon, like this one, sabi rito constant yung ano, di ba? Density. Pagka pagka ano, pagka incompressible, no? Pagka continuity equation, yan, no? Mass is equals to density area velocity. Pagka incompressible siya, cancel yung density. Okay? Kapag compressible flow, ito yan. Okay? So, ibig sabihin, meron kang density. Sana ba yan? Meron kang density. Okay, magkakaiba. Now, compressible yan, tandaan nyo. Incompressible ito, yung example na to. Nag-cancel yung nag-cancel yung density kasi parehas siya. Sa sobrang bagal niya, sa namin ito, sobrang bagal niya. No? Mabagal lang siya. Now, paano yung kung mabilis siya? Okay, pagka mabilis siya, ganito na siya. Yan, magkakaroon ng compression, so compressible. Ito na siya, nagkaroon ng shockwave. Okay? So, this is normal shockwave. Siyempre, dito, meron pa lang tayong rho, A, B. Pero makita mo, yung density niya, ito, at saka may density ka rito. Okay, what happened with the density is that kung dito mababa yung density mo, pagtawid mo rito sa shockwave, tataas yung density niya. So, the density is not constant. Yan o. At compressible po. Pero pagka incompressible, constant. What happened with the pressure? Pag pressure, pagpunta mo sa likuran, the pressure increases. Bakit? Kasi nagkakaroon ng compression. Ikaw nang mag-compress, di ba? So, tataas yung pressure niyan. So, ito, pagka gumano ka, tataas yan, no? So, dito ngayon sa likod, mataas yung pressure. And since mataas yung pressure sa likuran, tataas rin yung temperature, di ba? Pag yung pressure tumaas, yung temperature tataas. And what happened with your dynamic viscosity, okay? Or your sa compressible pala ito, V2, B1. Velocity yan, B1. Okay, so ito, this is B1. Okay, so what happened with the velocity of particles, no? Air particles. Di sa likod, delete siya. Okay, kasi babagal siya because of compression. And of course, if you have a Mach number greater than 1, paglipat mo rito, the Mach number is less than 1 because nga na-compress. So, ibig sabihin, mabagal. The activities here will be mabagal, no? Because of the shockwave formation. Okay? So, yan. So, that is now your compressible flow. Tanong, Sir, pagka ganyan ba all the way yan mangyayari? Hindi. Kasi normal shockwave yan, nakatindig So dito dati yan, siya nakatindig oh, di ba? Ito yung normal shockwave, yan. Paano yan kung sobrang bilis na dito? Pag sobrang bilis nito, ito na yung shockwave. Pag tama nito, yung shockwave, normal nakatindig yan. Gaganon na yan. Okay? Gaganon. Okay? So actually, pagka gumanyan yan, ganito yung tsura niya. Okay? Kasi ito yung point na may pressure. Yan. Mataas yung pressure dito sa point na to. And of course, as you move outward, the pressure decreases. So since the pressure decreases, what will happen? Itong shockwave na to, ito, which is 1, will expand. Mag-expand siya. Okay? Hindi yan all throughout na nakaganon yung ano. Okay? Same yan. At pagka nasa ano ka, speedboat, di ba? Dito, isa lang yan, isa. Pero pagka malayo na, marami na siya, di ba? Marami ng wave, no? Kasi, because the pressure is becoming lesser as you go farther, the wave separate. Okay? Magse-separate. Gaganon siya. Okay? So, ayan. So, ayan. So, that is now your normal shockwave. Ito, wag na natin masyadong aralin itong ito. Itong shockwave na ito. Okay? So, ipapakita ko lang kung paano naapektuhan yung aircraft. Okay? So, yan. So, dito na tayo sa extreme tube continuity example, no? So, meron tayong, kapag yung yung mass flow rate mo is, Mach number is less than or greater than 0.3, okay? Pagka 0.3, yung greater than 0.3, take note, 0.3. So, yung Mach number is velocity over speed of sound. Velocity over speed of sound. And speed of sound, it depends upon the altitude, di ba? The higher you are, the faster the aircraft because bumababa yung density mo at saka yung pressure. So, kapag Mach number is 0.3, ano yan? We have now the compressible flow. Compressible flow yan. Okay, compressible flow. So, ito yan, compressible flow. Ito yan, compressible flow. Kapag Mach number mo is less than 0.3, that is incompressible flow. So, what does it mean? The density will be constant kasi mabagal lang siya. Yan. Yan, mabagal siya eh. Okay? Mach number less than 0.3. Pag yung Mach number niya umakit na ng 0.3 pataas, that is now compressible flow. So, ibig sabihin, bakit may compressible flow? Kasi itong density mo is not constant. Ito yung compressible flow. Okay? So, ibig sabihin, yung Mach number, yung compression will start at Mach 0.3. Okay? So, ito na yan. Okay? So, magkakaiba na siya. Yan, may density 1, density 2. Diba? Pero pag ito mabagal, yung density 1 mo is the same as your density 2. Kasi wala siyang compression. Okay? So, yan ako. Minsan, namimiss siya ng teacher eh. Kung minsan, tinitignan ko yung faculty. Nagbibigay ng example, pinapasolve yung yung dito, pinapasolve niya yung rate flow. Eh, hindi naman rate flow na. Ito. Hindi rate flow yung concern dito. Yung concern dito is the mass flow. Pagka mabagal, rate flow. Kapag mabilis na yung flow, mass flow. Okay? Mass flow is constant. So later on, abutin ba? Okay. So ito So kunyari mabilis Ito ngayon kunyari dito, Mach number is equals to 1. Okay, ito yan, Mach number. Throat yan So dito, Mach number is low. Pag abot niya rito, yung Mach number is 1. Paglabas niya rito, Mach number is high. Mach number is high. Tingnan nyo para tumaas yung Mach number dito sa throat na to dito sa exhaust nozzle na to, kailangan abutin mo yung Mach number which is 1 dito sa throat. Okay? But the mass here should be the same as the mass dito and should be the same as the mass dito. Magbabago lang rito is the velocity. And velocity is related sa Mach number. So, pagka ito, inabot mo yung 1.0 wherein the velocity is equivalent to speed of sound, magkakaroon niya rito ng critical Mach number, magkakaroon rito ng shockwave or this is choking. Paglabas dito, Mach number becomes higher. So, ibig sabihin, velocity increases. So, velocity rito is less than, di ba? Dito. Ito. Kunyari, mabagal yan. Mabagal. Okay? This is now your velocity. Velocity. Para makuha natin yung difference between that. Mabagal lang siya. Okay? So, mabagal, lumusot. So, density is constant. Mabagal Okay? So, what will happen now is that yung Q mo rito, pareho yan ng Q rito, rate flow. At saka pareho yan ng rate flow rito. So, ibig sabihin, hindi ka gagamit ng rate flow rito sa may mabilis. Okay? Gagamitin mo rito sa mabilis yung mass. Gagamitin mo sa mabagal yung rate flow. Dito ngayon, what will happen here, yung rate flow mo is of course Q is equals to area times velocity. Now, dito ngayon, what will happen with the velocity as you hit the throat, velocity increases. Bakit? Kasi yung throat mo, lumiit yung area. So, bibilis yan dito. Pag abot niya rito, velocity decreases. Okay? So, ito, decrease. Ilagay natin. So, velocity increases. Pero, pag punta niya rin sa likod, paglabas niya rito, velocity decreases. Dito, iba yan. Pagka velocity decrease, pag tama niya rito, umabot siya sa Mach number, which is 1.0. Paglabas niya rin, hindi siya babagal. Bibilis pa. Yan, Kaya makita niyo yung mga rockets, Ganito yung itsura, di ba? So, pag ganon, okay. This is the exhaust nozzle, yung rocket. So, dapat paabuti niya rito sa throat 1.0 para supersonic yung exhaust niya. Now, ito, pag labas niya rito, ganun yan. Ito yung flow, Hindi yan didikit dito. Hindi yan didikit. Dito lang yan. Okay? So, it will push. So, ang bilis nito. Okay? This is Mach number is greater than 1. Now, kapag subsonic lang yan, mabagal, ganito yung tsura niyan. Pag exit niyan, nakalaminar yan. Okay? Nakalaminar. Dikit na dikit. Okay? Dikit na dikit siya. Okay? Dito, meron niya tinatawag na diverging angle. Yan. May angle yan between the surface at saka yung exhaust gas na lumalabas. Okay? So, yan. Pag mabilis to, Hindi yan halos dumidikit. So, ibig sabihin, kung ito mabilis, hindi siya dumidikit mismo rito sa surface nito. Okay? Dito lang siya banda. Pero dito, bago siya mag-exit, nakalayo siya. Yan, oh. Meron siya ritong divergent angle. Okay? So, for the rocket, siyempre, kailangan pabuti mo yung Mach number at the exhaust. More than Mach number 1 ka para mas maganda yung performance ng aircraft. Okay? So, yan. Pero tignan mo naman continuity equation lang yung ginamit. Okay? So, example, air having the standard sea level density as a velocity of 100 feet per second at a given section. At another section having half as much cross-section, having half as much cross-sectional area as the per section, the flow velocity is 400 mph. So 400 mph, pwede mo i-convert sa feet per second. Ito yan. 1.4 feet per second per miles per hour. Yan. What is the density at the second section? So sabi niya, air having the standard sea level density, okay, yung air, as a velocity of 100 at given section. At another section, having half as much cross-section, so half as much. So, nadagdagan ng kalahati, di ba? So, half as much as cross-section. So, yung area 1 is equals to area 1. Tapos, yung area 2, ang layo no? Area 2, sabi, at given section. At another section, having half as much cross-section area at the per section. So, sa area 2 is A1 plus 1 half. Ay, 1 half, sorry. 1 half A2. So, that is 3 over 2, di ba? Ay, so, sorry. So, we have 3 over 2. 3 over 2 area 1. That is your area 2. So, dito yan. Density 1, alam na natin, di ba? Area 1, alam natin. Velocity 2, velocity 1, alam natin. Ito na yan is equals to density 2, hindi natin alam. Area 2, siyempre alam natin, right? Area natin. Yung area 2 is 2/3, 3 over 2, sorry, 3 over 2 A1. Okay, A1. Then of course, we have velocity 2, which is 400 miles per hour. Di ba, speed of sound is 340 meter per second. So what is that in ano? So I do believe na sobra yung Mach number natin ito sa 0.3. So this is moving at compressible flow. So ibig sabihin, density 1 is not equivalent to density 2. You can solve now your density 2. Okay? Ito substitute mo rito. Siyempre ito, A1. Okay? 3 over 2, A1. Then of course, may A1 ka rito. So cancel yung A1. Okay? So ganun. So, hindi pwede direct so may konting math yun. So at section 1, of a tube with diameter of 12, the air velocity was determined at 80 feet per second. So, diameter, no, meron kang 12 inches. Sumuko mo yung area, di ba? If the design is to increase the air velocity to 120 feet per second, compute for the required diameter feet per second at section 2. Okay? So, 80 feet per second is very mabagal. So, we have A1, B1 is equals to Q. Okay? Rate flow lang yan. Magkakancel yung density kasi mabagal siya. So, this will become A2, B2. Okay? So kukunin mo ngayon yung diameter. So, syempre, yung diameter ito, substitute mo na lang pi diameter 2 squared over 4. Kasi ito, alam mo yung diameter dito di ba? 12 yan. 12 inches. Okay. So, yan. Then, at a certain section of a circular inlet duct with a cross-section area A1, the air velocity is 100 mph. What is the air velocity feet per second at the exit section where the area is 25% less that of the inlet? Okay, 25% that. So, area 2, area 1, sorry mo. Area 1 is equals to area 1, di ba? Para siyang ganun. Area 2 is equals to area 1 less than rabe, less than area 1, less than 0.25 area 1. Okay? So, yung area 1 mo ngayon dito, yung area 2 mo is equivalent to, siyempre, 0.75 area 1. Since this is mabagal, okay, so you will have how you have your area, no? Area 1, B1 is equals to area 2, B2. Yung area 2, B2 mo yan, okay? Meron kang area 1 ron, so kakancel yung A1, di ba? Then of course, you can solve what is the air velocity. Oh, makukuha mo yung B2. Okay, makukuha mo yung B2. Okay. Kasi this is this is one meeting only, no? 3 hours every week. So, para tong workshop, para tayo nagbo-workshop, no? So, if I told you to compute, you compute, okay? Kasi hindi nyo mararamdaman ang bilis nito, no? Pagka dugtong-dugtong na to, mabilis to. Dito lang mabagal kasi mula. Para pag sa dulo na, kalagitnaan, relax ka kasi nakuha mo. Pero pagka nasa kalagitnaan na tayo, tapos hindi mo nakuha yung unahan, hindi ka relax. Diba? Hindi ka maging relax. So, dapat maintindihan mo. Kaya medyo natin, salansan natin yan. So, nakuha nyo na. Kapag incompressible flow, the Mach number is 0.3 down. Kapag compressible flow, Mach number is 0.3 up. Okay? Now, pagka Mach number is 0.3 up, yung density mo hindi constant. Pagka Mach number mo is 0.3 down, which is incompressible, yung density mo is constant because ang bagal nung hangin. Ang bagal. Okay? So, ito yan. Applications, no? Okay. So, we have here the compressor, no, of the airplane. And of course, the air is being sucked inside, no? So, what will happen is that pag-abot niya rito, what will happen here? The pressure increases. The pressure increases. Pagpasok niya rito, mabilis yung higop niya. Okay? Pag bilis ng higop niya rito, yung compressor, may compressor ka rito, i-compress niya yung air. Pagka kinompress niya yung air, what will happen? The velocity decreases. Okay? Di-decrease yung based on Bernoulli. If the pressure increase, the velocity decrease. Okay? If the pressure decrease, the velocity increases. Punta tayo rito. Yan, no? If the pressure increase, the velocity decreases. Yan. Yan. So, Bernoulli yan. Okay? Yan yun. So, yan. So, that is the principle. Pagpasok niya rito, yan, i-compress pa siya rito, then, this is high pressure, pupunta siya sa likod. Okay? Ito ngayon, itong ano na to, itong inlet duct na to, ano to, hindi to solid. Halo yan, no? Halo. Ito, halo yan. Then, of course, pag umikot to, may mainit dito, mainit yung hangin. Some air will go inside, no? And tawag roon, bleed air. Punta rito, magsisirculate rito yan. Yung hangin na nasa loob rito, yung malinis na hangin, no? Malinis, no? Hindi siya yung galing sa loob ng makina, kundi sa labas ng makina. Kasi pagpasok niyan rito, yan. Meron niya tinatawag na bypass, no? Ito kasi, turbine, no? Ito, fan. Okay, turbo fan to eh. So assuming na turbo fan to, may hangin na dadaan dito, which is labas na ng labas ng engine, ito yung engine, okay? That is what you call bleed air. So may tubo yan, papunta roon, papasok yan dito, magro-rotate yan dito sa loob dito. And this will act as a heater. Kasi pag ito lumilipad, then malamig yung panahon, nag-a-ice, mag-a-ice ito, mag-yelo yan. No? So pag ito nag-ice, okay, it will disrupt the flow of air. Nadidislap niya ang flow of air and at the same time, bibigat yung aircraft dito. And pag bumigat yan, maapektuhan niya yung center of gravity, apektado yung longitudinal stability. So pumapasok tayo sa mga terminal. Maapektuhan niya yung longitudinal stability ng airplane during flight. At iyon ang importante na binabantayan. Kasi importante sa aircraft is longitudinal stability. Pagka bumaba yung aircraft ganyan, tama ka sa lupa. Pagka umangat na nun, tama ka rin sa lupa. Oh, but sir, nakaharap pa. Nakaharap sa taas. Hindi nga, pagka umarap kang pa ganun, lalaglag ka rin kasi mawawalan ka ng lift. Okay, so sa lupa ka pa rin babagsak. Pwede ka pwede bumagsak doon sa taas. Eh, puro baba yan. Okay? So, yan. Then, of course, we have here for the supersonic jet, dalawa yung inlet duct niya. Yan. So, meron siyang inlet duct rito. Yun yung ducting niya. Ito yung makina. So, makikita yung makina niya nasa likod. Okay? So, ito yung inlet duct sa for phantom. No? So, ito yung tinatawag na guide vane. No? Para mag-guide niya yung air na pumasok doon. Ito ang bakit tirano? Kasi ito yung surface nito. Ito yung surface niya. So, sobrang bilis ng hangin dito sa nguso nito. Itong nguso nito. What will happen? Magkakaroon ng turbulence dito. Okay? So, yung tatama rito ngayon sa engine. Okay? Papasok sa engine is turbulent air. So, may hirapan tong mag-compress. No? Kaya niya nilagyan ng bakod dito. Bakod. Okay, that is a guide. No? Para yung tatama sa kanya, hindi turbulence. No? Diretso ron. Dito yung turbulence, dito daraan sa gitna. Yung turbulence, dito daraan sa gitna nitong fuselage, itong fuselage, at saka ito. Daraan yan dito. Yun dito, papasok rito, yung diretso. Now, ito sa design kasi ng aircraft, hindi naman yan pampapogi lang. Meron niyang purpose. Kasi pagka dinekorasyonan mo yan, dekorasyon ha. Pag dinekorasyonan mo yan, bibigat yan. Gaganda nga itsura, pero bibigat, no? But it will not serve any purpose, no? it will just slow down the performance of the aircraft. So, yan ang halaga niya. Kita mo naman yung kalikutan ng isip niya mga yan, di ba? Yan. So, diretso. Okay? So, dito ngayon makikita mo sa aircraft, di ba? Kung minsan pagka lumilipad dito, dito yung turbulence, di ba? Narin yung turbulence. Then, of course, we have also the aerospace. No? As I've said, okay, we have with the pins and so on. So, this was already discussed dito kanina. Yan. So, it will separate kapag mabagal, but pagka mabagal, it will have a laminar flow sa surface nito. Gagapangin niya yan. Nakadikit siya. Okay? Kapag high speed, nakahiwalay siya. Yan, umihiwalay siya. So, ibig sabihin, the heat here will not touch this portion. But of course, may init yan. Diba? Ito sabog. Sabog siya. Okay? So, yan. So, these are the supersonic rocket. No? Then afterwards, we have here your rocket booster. Okay, this is the rocket booster. Paglabas niyan dito, meron niyang angle. No? So, pressure exit, velocity exit. Okay? So, hydrogen. Hydrogen and oxygen. No? Hydrogen and oxygen. So, we have a mass. Makita mo rito, mass is equals to density, area, velocity. Makita mo yung dot sa ibabaw, ibig sabihin niya mass flow. Ibig sabihin, the mass flow will be constant from here. Yan, hanggang dito lumabas. So, paglabas niya rito, yung velocity nito, tataas, the same at speed of sound. So, magkakaroon ng Mach number dito. Pag yung Mach number niya rito 1, kailangan establish mo yung 1. Pag hindi ka umabot sa 1, hindi siya bibilis rito, kundi babagal siya. Okay, kailangan, tingnan nyo kailangan 1. Yung sa nozzle, sa throat. Okay, pagka babagal siya, what will happen? Babagal ka rito sa labas. Pero pag mabilis siya rito at Mach 1, instead na, kasi di ba lumaki yung area, pag laki ng area, dapat babagal ka. Hindi. Pag ito, nag-Mach number ka or supersonic flow ka rito, paglabas mo rito, bibilis ka palalo. Okay? Kung Mach 1 ka rito, baka yung sikat ditong exhaust gas umabot ng Mach 2. So, iyan ang tutulak sa rocket, no? So, ngayon nga, di ba hypersonic, di ba? Sa mga China, sabi hypersonic. So, ibig sabihin, yung bumibigay ng diferensya roon is the design of the nozzle. Nozzle design. Okay? Yan, no? Nozzle design yung mahalaga. Okay? Then, of course, we have here the rocket nozzle requirements. Ito yung ginawa, no? Ito kasi, this is made of standard aerospace material. Okay? So, makikita nyo rito, pinakamanipis rito portion is the throat, right? Manipis ang throat yan. If you will look at it, no? Manipis yan. Okay? Siyempre dito, manipis rin. Okay? Pero maluwag siya eh. Tapos dito, manipis rin. Temperature rito, is low. Temperature is high. Di ba? Kanina, pinunta natin. No? Pressure kasi high. Okay? And of course, temperature high. Okay? So, tingnan niyo. Pag ito, what will happen? Tataas yung temperature niya rito. So, ibig sabihin, magre-red dot ito. Magre-red dot. Okay? So, ito yung ina-explain ko sa mga bata ko dati ro. Naggawa kami na sa may Holy. No? Sabi ko sa kanila, huwag natin i-adapt yan kasi yung bakal na ginagamit natin, hindi naman standard aerospace. So, sabi ko, tubo na lang yan, diretsong tubo. Okay? Then, ikat mo rito. I mean, ito yung loob So, ayan, that is the tube, no? So, ito sa loob, ayan, marunong kayong drawing, di ba? Yan. So, ibig sabihin, buo to, makikita mo. Parang tubo lang siya, pero sa loob, may kurbada siyang ganito. Kaya sabi ko, magsusuperheat dito, dito magkakaroon ng superheat. Mahina yung materials natin pupunitin yan, Okay? So, nagpagawa, ganun pa rin, matitigas yung ulo eh. Paggawa ng ganito kasi, sabi lang, sir, hindi naman magbumukang rocket yan, pagkatubo lang yan, diretsong ganun, di ba? Sabi ko yung ano kasi riyan, may hirap riyan. Sabi ko, kasi pina-simulate pa, yung problema kasi sinimulate pa sa kinakad pa nila yung finite element. Sinimulate namin eh. Oo nga, tama. Tama naman yung binibigay ng simulation, pero yung materialis mo hindi naman standard, di ba? Bakit? Kasi di ba yung mga ano, yung mga bakal na binibili sa hardware, ganito yan. Kung ima-microscope mo yan, may mga butas yan, may mga pores. Pores. P-O-R-E. Eh marami. With S, di ba? Marami yan dito. So, hindi siya makinis, no? Ito, pagka tinoron mo yan, meron niya mga ganun. And of course, pagka sumikat to, it will penetrate the butas, di ba? Yung mga dimple-dimple niya, ipe-penetrate yan hanggang maipit dito yung temperature, lalo tataas yan. Okay? So ito, sabi na sir, hindi eh. Nung pinagawa ko, dumating ganun. Kasi bahala ka, i-testing nyo. Sumabog. Sumabog. Sumabog yung, ano, sumabog yung racket, no? Kasi nung tinignan namin, nakuha, sumabog, tumalsik to eh. Tumalsik na nakita. Umano, ito, naputol eh. Ito. Ito, bumengkong dito, papunta rito. Tapos, bumaluktot siya. Yan. So, ibig sabihin, sumingaw rito, banda, kasi sumabog. Okay? So, yun. Kasi, at saka ito nga makapal eh. Pero actually, if you will look at the, ano, rocket booster, sa Smithsonian, no? Sa Smithsonian, may kita mo yung mga rocket booster na pinalipad dati. So may kita nyo, parang ano lang eh, parang kaldero lang yung nipis eh. Oh, pero siyempre, stainless, no? Stainless yan. So hindi mo dapat pakapalin kasi bibigat yan. Dapat, materials, consider mo. Oh, tapos na. Okay, we will have 2 minutes. Oh, ayaw. We have 2 minutes break. 2 minutes break, then we will continue discussion. Ay, sorry. 2 minutes pala. Okay na? Maganda na rito pagka online kahit gusot-gusot. so, so let's continue. Okay, so we have that and of course. Okay, Karil.
Sir, ask lang po namin if ipo-provide niyo po sir yung materials po sa classroom.
O, syempre. Oh, but not
Okay po sir, thank
now,
you po.
sa susunod. Okay. Ayusin ko muna. Okay, let's have continuation. So, aerodynamic body. So, ano na to? This is the last for aerodynamic body. Okay. Aerohydrodynamics. Define the concept of streamline and turbulent flow. Apply conservation of mass to control volume. Use Bernoulli's equation to calculate pressure and velocity in a flow. Of course, we have design and use of low-speed wind tunnel testing for commercial aircraft, wind tunnel application for aerospace, wind tunnel application for automobile, design and use of high-speed wind tunnel. Actually, you have your wind tunnel, di ba? Kasi pumasyal ako rin nakita ko yun. Kaya lang, anyway. So, we have here the streamline and turbulence. So, it was already discussed, no? So, this is streamline, no? Streamlining in aerodynamics, the contouring of an object such as an aircraft body to reduce its drag or resistance to motion through a stream of air. A moving body can cause the air to flow around it in definite patterns, the component of which are called streamlines. Okay? So you can see that this is an airfoil. An airfoil is the cross-sectional of the wing. Okay? So yan yung flow. Supposedly yung flow sa circular, ito rin yung flow niya. Okay? Yan yung flow. Actually kasi, ginamit yan dito dati before, no? Or that is circulation due to uh, lift due to circulation. Okay, lift due to circulation. If you have here a tube, okay, this is a tube, no? Patama mo yan ng hangin, okay? Pag tinama mo yung hangin, what will happen is that streamline yan. So the turbulent flow will happen at the very back, no? Dito mangyari yung flow. But of course, that is for a incompressible lang, incompressible. Pero pag ito binirisa mo yung tama niya nito, magkakaroon to ng shockwave dito. Okay? So let's say mabagal. Okay? So bagal, so dikit-dikit lang siya rito, dikit. Okay? Then if ever na magkaroon ng turbulence yan, wala na rito, narito na sa likod. Okay? Now, noong araw, paano yun ipoproduce yung lift? Siyempre, pag steady yan, wala. So, all you have to do is to rotate yung cylinder. I-rotate mo siya. So, pag tama niya rito, i-rotate mo, the tendency nito is mag-produce na lift. The same one with the cylinder. Okay, let's say a container, a drum. No? Ilagay mo sa ilalim ng tubig. Pag binitaw mo yan, akit yan. Akit. Pag akit yan, tatalbog yan sa ibabaw. Makita mo na umiikot siya, umiikot. Okay, umiikot. Talbog yan dito, umiikot. So, ibig sabihin, habang umakit siya, nagro-rotate siya. Okay? And that is due to, lift due to rotation. Okay? Or circulation. Now, tanong, paano natin yung gagawin na hindi siya dapat mag-circulate? Hindi na pwede yung wing nagsisirculate, diba? So, binago ngayon yung itsura ng pakpak. Ganito ang ginawa. Yan. And this is what you call unsymmetrical wing because the kurbada sa ibabaw is not the same curve at the ilalim. Diba? So, ito na yan. Okay? So, makita mo, yung curve rito is bigger than the curve at the ilalim. Okay? So, dito yan. So, ito kaya makikita mo, sabi, kung ano rin particle dito, the particle will meet at the back. Okay? So, pag dumaan yung particle dito, ito sa si A at saka si B, okay, dito siya. Pag pumunta siya sa likod, A pa rin yan. at saka si B pa rin yan. So, ibig sabihin, para mag-meet sila riyan, mataas yung kurbada nito, velocity should be high. Okay? And the velocity should be low. Kasi kung bibilisan niya to, mauna siya rin sa ilalim, mahuli pa yung sa A. So, dapat mabilis. Okay? So, pagka velocity is high, the pressure is low. Yan, yung pressure. So, sabi ni Bernoulli yan eh, pagka velocity tumaas, pressure bababa. At incompressible flow. Kasi kung high speed, wala si Bernoulli, hindi pwede. And the pressure is high sa ilalim. So, may kita nyo. But of course, pressure is equals to force over area, right? Over area. Kung kukunin mo yung force is equivalent to pressure times area. So, may pressure ka rito, may area ka rin, di ba? So, ito yung area niyan. So, if you will look at this, the area at the top, projected area, is the same area projected downward from the bottom. Okay? But of course, the curvature is not the same. So what will happen is that because of the difference in pressure, you can produce now your force. This is now the force which happened at the top. Okay, this is now the force. Okay, so there is a force downward. Okay, and this is a force upward. Naging Christmas tree. Yeah. So, ibig sabihin, mas malaki yung force sa ilalim, mas maliit yung force sa ibabaw. So, this is your force upper. This is your force lower. Then, the difference of this, will produce, of course, lift. This will produce lift. Okay? So, what will happen, kung mas malakas yung force dito, mahina yung force dito, itutulak niya yung paakyat. So, tataas siya. Okay? So, that is the principle of pressure is equals to force over area. If only mabagal, kasi pagka mabagal, ganito lang ang itsura ng airfoil natin or the cross-section of the wing. Kapag mabilis yan, ito yan. Kung supersonic yan, diamond. Okay, diamond yung cross-section natin. Yan. Diamond. Okay? Ito ang tinatawag na knife edge, no? Yung dulo niya. No? Kaya pagka pakalat-kalat ka, tumama ka rin, baka masugatan. Then of course, what happened if we increase the frictional drag, no? So may kita nyo, pagka in-increase natin, ito yan. So as I've said, yung turbulent flow nasa likod. Yung turbulent flow nito nasa ibabaw because itinaas mo yung angle of attack. Okay? Angle of attack. Okay? Nilagyan mo ng angle. Okay? So that is alpha. Pagka nilagay mo, syempre, what will happen is that laminar flow pa rin siya rin. Kanina, discuss yung laminar flow. Mag-jump siya. Okay, jump, then turbulent flow. So, dito kanina, lahat to gumagawa ng lift. Okay, kasi buo yung area mo, right? Dito, ito lang yung puproduce ng lift, ito puproduce ng drag. No? So, this point will drop because of the turbulent, ito yung lift niya rito, maliit lang. Okay? Then of course, dito, malaki pa rin. Dito, okay, maliit. Ay, yeah, malaki baliktad. Sorry. So dito yan. So dito, pataas pa rin. Lagyan natin. Okay. So yan, paakyat yan. Ito pababa kasi meron siyang turbulent flow. So what will happen now is that you will reduce your lift. Okay? So, pagka ganito, nagkaroon ng turbulence, it will of course alter also the balance of the airplane during cruising flight. Saan ito mangyayari? Ganito. Kapag lumilipad yung aeroplane, no, at cruising altitude, habang bumibilis siya, what will happen? There is a tendency na umaakyat siya. Okay? Umaakyat. So, lumilipad yan, umaakyat yan. Because sa continuous yan. So, ibig sabihin, nag-i-increase ka ng lift. Okay? Pagka nag-i-increase ka ng lift, kasing airplane, umaakyat yung nose niyan. Okay? So, what is the tendency is that you will have a layer of turbulence at the back. Okay? So, kailangan bantayan mo yung longitudinal stability na lagi ka nakadiretso. Then, yan. So, we have mag-stall. Stall is when the wing uh, lost its lift. Okay? Maglo-loss siya ng lift. Okay? But of course, dito bear with me, maraming klaseng stall. Itong usapan rito is stall only because of turbulence. No? Kaya huwag niyo i-confine sarili niyo sa turbulence lang. Marami. No? Along the way, makikita niyo, ang daming stall dito. Maraming production ng stall. Okay? So, yan na. So, you have that. Okay? Then, of course, we will now consider your sa ngayon, no, i-consider natin yung wing, no? Kasi the wing is the one that is carrying the aircraft, no? Yung wing. And then, of course, we have here the drag. Of course, the drag is the air resistance, okay? Then, of course, we have the weight, okay? So, kailangan tama lang yung weight mo. That is why sa aircraft, masyadong gwardyado yung gross weight. Kasi the gross weight, the heavier the airplane, the more it will affect the performance. Okay? Kasi mabigat. Okay? So, hindi siya basta-basta bubuhat kasi mabigat. Okay? But of course, noong araw, no, nilalagyan ng rocket yan para umakit kagad. Kasi the velocity will increase the lift, di ba? The lift is a function of velocity. If you increase the velocity, ito yung equation ng lift. Lift is equals to CL. Papakita ko lang, CL rho over 2 SB squared. So, directly proportional yung lift. If you increase the velocity, you will produce a lift, a higher lift. Now, noong araw, yung C123, no? C123 noon, evacuate yung, saan ba nangyari? Sa Vietnam, di ba? I-evacuate yan, no? Kinabitan nila ng jato sa gilid. So, kahit overload yung aeroplano, umangat siya. Umangat. So, bakit? Paano niya ginawa? So, lahat sumakay. Lahat sakay. Full pack siya nakasakay, no? Kaso may jato yung naka-ready na yung jato ng C123. Pag take off niya, pinapire niya yung rocket. Pag fire ng rocket, ang bilis sa runway niya. Ang bilis. So, kukuha siya ng lift because of the take-off speed. Ang bilis ng take-off speed, kaya buhat siya, bubuhat. Kasi that is a function of your velocity. Yung wing area mo, hindi naman nagbabago yan. Palaging iyan yung wing area mo. Density, of course, depende yan sa altitude. At saka yung coefficient of lift, depende yan sa coefficient of lift ng wing. Kasi ito, may design to, meron na tawag na coefficient of lift para dito sa lift, at saka meron ka tinatawag na coefficient of drag para sa drag. Okay? So, ito ang kailangan. Diba? Pag yan may weights, okay, mabigat siya, maapektuhan ito. Maapektuhan yung lift. Pero, i-increase natin yung velocity, squared pa yan. So, mabilis yung akyat itong aircraft. Okay? So, yung ginamit ron, jato, Jato. Pero ngayon, wala na ito. Ginamit na sa Vietnam War nung tumakbo na yung mga Amerikano, no? Kasi natalo, di ba? Natalo sila. So, jato, jet assisted takeoff. Yan yung meaning niyan. Jet-assisted takeoff. So, jet-assisted takeoff yan, rocket yung nakakabit sa gilid ng aeroplano. Siyempre, dalawa, kabilaan. And that rocket is disposable. Hindi yun nire-repair. Pag tinanggal yun, palit ng bago. Kaya yung aeroplano, tumatakbo ang lakas ng apoy rito kasi rocket yung tumutulak sa kanya. Okay? Kasi yung issue naman rito, pag yan umakyat, naka-airborne yan, nag-airborne na, kahit heavy yan, bahala ng piloto na i-ano niya, i-correct niya uh, yung yung magiging problem. Okay? Kasi yung ano ron, the purpose there is to leave the country. Okay? So, ginamit yan yung jato niya. So, tingnan yung jato, no? Alam na kasi nila na matitalo na sila sa Vietnam noon. Ano ba yun? Ayun, di ba? Di ba, tumakas sila yung sinabi nila, ano ba yun? We won the battle. Di ba? Tama naman eh. We won the battle but we lost the war. Yun. Yun yung mga ang gagaling eh, di ba? Natalo na eh. Gumawa pa ng parang praise. No? So sabi nila, we won the battle kasi ang dami lang napatay eh. But we lost the war. So evacuate, di ba? Kennedy, di ba? Ay, hindi. Diba na ganun? Ano yata? Yung sa Watergate scandal. Okay. So, Bernoulli's principle. So, Bernoulli, no? In fluid dynamics, Bernoulli's principle states that an increase in the speed of fluid occurs simultaneously with a decrease in static pressure or a decrease in the fluid's potential energy. The principle is named after Daniel Bernoulli, who published it in his book. Okay, that is in 1738. Kita nyo, 1738 na yan. Dito, mukhang hindi pa nakakita ng libro. Although Bernoulli deduced that pressure decreases when the flow speed increases. But this is only good for incompressible flow. Take note, pagka umabot tayo sa performance at high speed, walang Bernoulli ron. Kasi baliktad na. If the pressure increases, velocity decreases. But at high speed, if the pressure increases, velocity increases. Okay? Narito ba? Wala. Doon pala sa kabila, no? Sa ano, di ba? Okay? So, baliktad. Okay? Although Bernoulli deduced the pressure decreases when the flow speed increases. It was Leonhard Euler who derived Bernoulli's equation in its usual form in 1752. Ito si Euler yung ano, Euler. No? So, yan. Yan ang nag-devise ng Bernoulli's equation sa usual formula. The principle is only applicable for isentropic flow. Ayan, isentropic flow when the effects of irreversible process like turbulence and non-adiabatic process. So that is why I gave you the adiabatic no nakaraan, di ba? Yung pressure density temperature relationship. Yung P over P of O is equals to rho over rho of O. Rho over rho of O is equals to P over P of O multiplied by T of O over T, di ba? Bernoulli's principle can be applied to various types of fluid flow, resulting in various forms of Bernoulli's equation. The simple form of Bernoulli's equation is valid for incompressible. Okay, so incompressible. Most liquid flows and gases move at low Mach number. Okay, so incompressible lang siya. More advanced forms may be applied to compressible flows at higher Mach number. Yan. Pero specific siya sa incompressible flow. So, ibig sabihin ganitong pakpak, pwede siya. Pero pagka diamond shape, yan yung diamond shape. Hindi na siya masyadong ina-apply. Okay? So, ang haba. So, dito na tayo. What is the Bernoulli's principle example? No? So ito yan, we have a high velocity, okay, low pressure, then we have low pressure, high pressure sila. Okay? Leak due to pressure difference. Okay, so it was discussed kanina. May pressure difference tayo, so the pressure difference will of course speak of the leak difference. Okay? So this wing will move upward. Then what is now the incompressible flow? Sabi niya, static flow, static, alam niyo na static natin, di ba? Yung static pressure sa gilid ng eroplano, last time pinag-usapan natin. So we have static pressure plus dynamic pressure is equals to constant. So mangyari niya, we have now P, static pressure, P1 plus rho B1 squared over 2 is equals to P2 plus rho B2 squared over 2. Okay? P2. Ito ngayon yung hahanapin mong pressure. Okay? Ito yung tinatawag natin na stagnation pressure. Okay? So, and this is dynamic pressure. Yung rho over 2B squared. So, ito siya. So, P is static pressure. Rho is the density and velocity. Dynamic is 1/2 rho B squared. Okay? The more you increase the velocity, the higher you will get a stagnation pressure or dynamic pressure. So, ito yung dynamic pressure natin. Okay? Misa kasi tawag stagnation eh. Stagnation pressure. Yeah. So, yeah. Okay? Then ito, yung galing to si static port. Static port. Then also, we have yung P2 is static port. We have P2 tube. Yan, pressure na yan. Okay? So, kung alam mo yung static port at saka yung P2 tube, makukuha mo yung final velocity. Kasi alam mo yung initial velocity ng aircraft. Eh. So, makukuha mo yung final velocity based on the difference between the static port, alam nyo kung saan nanggagaling static port sa butas, doon sa bandang katawan ng aeroplano. At saka nung P2 tube pressure, yung P2 tube, di ba, nasa pakpak. Nariyan, ganon. Okay? Then, of course, there is a difference of that. You can get now the final velocity. Okay? So, dito na. You can get now the difference in pressure is rho over 2, B2 squared minus B1. Equate lang, no? Equate lang. And of course, that dynamic pressure is now what you call stagnation pressure or the total pressure. So, see? So, mga ito eh. Ito mga netizen natin, puro kalokohan. Gusto lang magaya sa Indonesia. Bahala siya. So, yan. So, we have here your deep. Okay, we have dynamic pressure. Then, of course, we will call now this stagnation pressure or total pressure. So, halos pare-pares yan. Okay? So, afterwards, ito, we have the open wind tunnel with closed section. No? So, ito, dito natin tinetest yung yung aircraft. Okay? So this is the model. What will happen? Kung ito, open cycle to, so ibig sabihin, this is incompressible flow. Incompressible yan. No? So higop siya rito, takbo yung ano rito. But of course, ito, magwiwir to magwiwir. Iikot yan because the propeller is rotating, and of course, it will rotate here. No? Magro-rotate yan dito, magro-rotate yan kasi yung higop niya paikot. Okay? So what happened is that iikot rin dito. But of course, nilagyan niya dito, hindi nga na nakalagay. Meron rin itong honeycomb. Okay? Para pag-ikot nito, yung hangin dito, higupin niya, diretso. Kasi pag hindi yan, pag, pag walang honeycomb, what will happen is that yung tatama dito sa model natin is turbulent flow. Dito may honeycomb rin na tatawag dito. Yan. Okay? So, yan yung ano. Okay, we have now this one. This is the use for the wind tunnel. Of course, applying the velocity and the pressure. You can get now the pressure here. Okay? O paano makukuha yung pressure dito? Siyempre, lalagyan mo rito ng pitot tube para kunin niya yung pressure dito sa loob. And the pressure inside, because the velocity is high, pressure is low, most probably, kung may pinto yan dito, the pressure outside is greater. Kung greater yung pressure rito, there is what you call vacuum sa loob. Okay? Yan. Kasi nag-design ako dito dati, yung wind tunnel, doon sa 20 feet no, na metal. Okay, so, inaugurate, no? Inaugurate yan. Siyempre, ano lang yan, transparent rin siya. Transparent, okay. So, siyempre, tatawa nga ako eh. Yung president kasi na kayo noon, hindi naman siya engineer, no? So, in-inspect niya kasi 20 foot yung haba 20 feet yung haba. Tapos talk siya gano'n. Sabi niya, very, impressed raw siya. Kasi nakapag-produce gano'n, no? Octagonal to yung gilid dito. Hindi siya circular. Yung cross-section niya, octagonal. Sabi niya, ganda. Kaya lang, nakalimutan raw lagyan ng lock. Itong pinto, okay lang raw yung kaya lang dito nakakapit niya. Yung bukas mo nito, pataas, pag gano'n. Okay. Sabi niya, kaya lang kulang yung design. Sabi niya, walang lock. Ewan ko nabibili po, kung nagbibiro o talagang yun ang pagkakalam niya. Wala raw lock. Pinapayak ko lang. Kulang raw yung design. Ganun. Sabi ko, sige. So, tapos na. Kinuha ko yung mga bataan ko rin. Sabi ko, paandarin nyo. So, nang pinaandarin lang. Ito, 60 horsepower yung inabit ko rito eh. Pero impeller. Hindi propeller, impeller type. Okay. So, ganito yung impeller oh. Hindi nga yung makina. Paano pala. Hihigop yan, itatapon niya ron yung hangin. So, kung propeller kasi maingay, ito tahimik to, sumasagit-sit lang siya. Okay. Then, of course, it will be thrown outside. Sabi ko, sige, paandarin nyo. Pinaandar ngayon. Pinaandar. So, pag paandar nila, since the pressure here is greater and the pressure inside is lower, this door closed. Nag-close siya. Okay? Sabi ko, sige, buksan mo. Siyempre, hindi mo buksan. Sinusungkit na nga, hindi mo buksan eh. So, paano mo buksan yan eh? Mas mababa yung pressure sa loob. Di ba? mas mababa yung pressure sa loob. Okay? So, yun. So, sabi ko, kailan po ba ng lock? Siyempre hindi, di ba? Then, of course, parang kapag may bagyo, di ba? Yung hangin sa labas, malakas, di ba? And of course, yung pressure sa labas, kaya nga low pressure area, di ba? Low. And of course, sa loob ng bahay mo is high pressure. So what will happen, hindi mo bubuksan yung pinto, di ba? Especially kung yung pinto mo sa loob yung bukasan, di ba? Hindi mo bubuksan kasi mas mataas yung pressure sa loob kaysa sa labas. Pero siyempre, iba sasabihin hindi mo bubuksan yan, malakas yung hangin eh. Hindi, dapat mababa yung pressure, di ba? So, yun. Okay, this is an open return, no? So, we have here the fan and so on and so forth. Then, of course, this is how you will do that, no? So, ito, meron yan yung wind tunnel nyo, no? So, pag takbo rito, what will happen? Ito kasi, itong water na to is pantay yan. Pagpunta niya rito, what will happen? The pressure here is high, right? The pressure is high because the velocity is low. Pagpunta niya rito, the velocity is high, so the pressure is low. Velocity is high, pressure is low. So, itutulak niya niyan, di ba? Pag tinulak niya, magkakaroon kayo ng difference in height. So, dito yung banda. Then, masosolve yan, di ba? Physics. Then, paglabas niya rito, what will happen now is that the pressure will be atmospheric. So, ito, babalik to sa pantay. Pantay na naman yan dito. Okay? So, ito. So, this is the pressure. Okay? Pressure high, pressure low, pressure high. Okay? So, iyan yung position kapag incompressible flow. Okay? Pressure high, velocity low. Pressure low, velocity high. And this portion is this one. Actually, yung dito sa likod dito, ito tinatawag natin na local speed. Nakarinig pa kayo na local speed. Yan. Pag sinabi mo local speed, the speed here will be the same as the speed at the exit. So the speed here is, the local speed is constant, no? But of course, the velocity here or the speed here is higher. Okay? So incompressible yan kasi yung compressible, nakasara. Dulo-dulo, nakasara. No? So ito yan, airflow simulation. No? Ito yung another, no? So we have the flow, yan, meron na siyang straightener, no? And of course, dito, nilagyan niya nito. Asa na ba? Ito, dapat meron kang ilan. Ito yung tinatawag na wind guide, no? Kasi, yung higop nito, hindi yan dito diretso. Kumukuha yan dito sa gilid. Okay? Mas mabilis kapag may wind guide ka. May wind guide. Okay? Kasi pag ito, tinanggalan mo ng ganyan, mahina yung higop niyan. Dapat may ganito. Okay? Para sa vacuum cleaner, di ba may ganyan? Okay, so this is for a maths. Ito, makita niyo may pressure. Ito yung pressure. Yung pressure dito sa surface is greater than the pressure at the very far. Okay, nag-open kasi yan. Dito, mataas yung pressure niya kasi nasa surface. Pero habang tumataas siya, lumalayo, lumilit yung pressure. Okay? So, this is a closed wind tunnel. Okay? So, sa closed wind tunnel, of course, ito siya, actuator fan. Hinihigop niya lang yan. Ito ngayon yung supporting. Meron ba tayong high speed? Wala. Okay, so iigupin niya papunta ron at papunta na. So may ka rito, may motor, then iigupin niya. Pabalik-balik lang yung hangin niya. Pabalik-balik. Okay? So we have a actuator fan, then of course guide vanes. Okay, pabalik-balik lang siya. So this is what you call a return flow or a closed wind tunnel. Okay, isa kasi open eh. So ito, paikot-ikot lang. Okay. In NASA, yung ginagamit na malaki. No? Malaki aeroplano kasi malaki aeroplano. At saka wala pa tayong high-speed ano rin. Okay, example, compute for the stagnation pressure at a blunt object flying at 120 feet per second under standard level condition. So, compute for stagnation pressure. So, PS, stagnation pressure, sabi, is 1/2 rho B squared. Diba? Sabi niya, what is the stagnation pressure at sea level? So, 120 feet per second, substitute mo rho, you can get now your PS. Stagnation pressure. Okay, ito. Then calculate the pressure difference for air passing through the wind tunnel. Contraction section 80 feet per second at test section at 150 feet per second. Assume standard sea level. Sabi, pressure difference. So we have ito. We have P1 plus rho B1 squared over 2 is equals to P2 plus rho over 2 rho B2 squared. Okay? So substitute mo rin now, we have now P1 minus P2. So this is now your pressure difference, di ba? P1 minus P2 is equals to the difference in pressure, which is delta P. Delta P. Ilagay mo yun doon, we have now rho B2 squared over 2 minus, lipat doon, rho B1 squared over 2. So common natin is rho over 2. So we have B2 squared minus B1. So this is now your difference in pressure. Yan. So that is for incompressible. Then the wind tunnel, no? The wind tunnel has a test section at station 2 of 4 feet by 4.25 feet. So that is rectangular. At station 1, its cross-section measures 13 feet by 13 feet. No? At some tunnel speed, the water manometer reading is 14 inches. Ito, 14 inches, okay? 14 inches. Siyempre, makukuha yung pressure, di ba? So, 14 inches siya. The manometer liquid has specific gravity of 0.85. Calculate the airspeed in the test section. Assume that the flow is compressible and that standard sea level condition. Specific gravity, yun, asterisk, is defined as the ratio between the mass density physics, density of parang hindi na tayo maganap, of a substance to that of water. Water density is 1.94 slug per feet cube. The specific weight W of water is therefore 30.26 to 2.47 pounds per feet cube. Okay. What is now your change in pressure? Ito ang formula. Okay. Delta P is equals to P1 minus P2 at SG, okay, specific gravity multiplied by W, which is specific weight of water. Okay. So, yan. Nakuha na. Okay, so that's formula P6 yan eh, di ba? So, yan. No? Specific weight, specific gravity. Okay. Then, example. Okay, a wind tunnel is so designed to attain an air velocity of 250 feet per second at test section with cross-sectional area of 144 square inch. If the air velocity at the inlet is 100, moving at standard, standard to, with cross-section area of 225 square inch, compute for the test section pressure in PSM. Madali na yan the same na yan. Fix naman yung formula eh. Okay. Kaya karugtong pala to yan. So yan So, meron ka na. Why? Air velocity ito at the test section. With cross-sectional area ito, if the air velocity at the inlet moving at standard sea level condition with cross-section of 225, compute for the test section pressure in PSM. So, alam na, di ba? So, palit siya. Okay? Okay, a wind tunnel is so designed to an air velocity of at the test section. Ito yung test section So this is your B at test section. With a cross-sectional area of 144, so meron tayo rito cross-sectional area, test section, or throat. Okay? If the air velocity at the inlet, ito. So B inlet. So cross-section niya is, of course, A inlet is equals to 225. Okay? So, what is compute for the test section pressure in PSM? So, dali na. Kukunin mo rito yung P2. Okay, so gagamitin mo ito Bernoulli, no? PI plus rho VI squared over 2 is equals to P throat. Inikot pa no? Plus rho over 2 V2. Yan, inikot pa alam mo na yung velocity So, ito yung kukunin mo, P at the throat. So, ginulo lang nitong area. Okay. So, afterwards, this is now the wind tunnel testing of a commercial aircraft. No? So, this is from other source. Okay. So, yan. Then, of course, this is a rocket. No? So, it is being tested in a wind tunnel. Okay. So, ito kung minsan, full size. No? 1:1 yung nilalagay nila yan. So, yan. So, malaking wind tunnel yan. Okay. Ito, 1:1 yan. Then, of course, you have wind tunnel automotive application. Ito yan. No? So, the tendency nito, pag sports car, no, last week ago, 2 weeks. 2 weeks siya, no? Di sa unit ko. Di sa harap, no? Sa harap may naka-parking rin, Corvette na, na sports car. Kulay white. So, that is almost 2 weeks na. No? Kaya sabi ko sa Lord, sabi ko, ano nyo nga yan kung sino may-ari niyan? Sabi ko, kasi kung ako yung may-ari niyan, hindi ko ipaparking sa kalsada, di ba? Corvette May sports car, no? Kulay white. Sabi ng guard sa akin, sir, baka sa DPWH. Baka sa DPWH. Pero lumabas ako ng paso, nagtapon ako ng garbage doon sa ilalim. Dewasan na, sir, umalis na. So, hindi ka naman judgmental, pero yung mga nagpupunas-punas, mukhang hindi naman kaya bumili ng Corvette. No? Dapat doon siya sa ilalim sa basement, pinarking. No? Yung mayroon po, baka makasabitan, di ba? Okay, how much is Corvette? Diba? for 2 weeks. Inuulan, iniinita, nasa kalsada. Ginawang bios eh. So, yan na. Okay? So, dito ngayon, once na umandar yung of course, later on, we will apply this with the airplane. Pagka umandar siya, what will happen is that itong gulong na to, pinupush yan up downward. Okay? Because of the air. Okay? Yung air na yan. So, pinupush siya downward. No? So, that is laminar flow. Dito hanggang laminar flow rito. Then, of course, yung sa back niya. Then, the tendency nito, what happen is that this will move upward because this will be compressed. Yung tire nito, kino-compress niya at high speed siya. No? Tumatakbo siya. No? Hindi high speed, high speed. No? Kasi pagka tumakbo siya ng 200, high speed na yan. Diba? So, ipupush yan. Okay? So, what will happen na angat ito? Kaya dito sa likod, meron yung ginatawag na spoiler. Okay? Pagka magkaroon siya ng downward force, spoiler. No? Yung iba kasi pinandidecoration to ang bagal-bagal naman yung sasakyan, di ba? Yan, para i-push niya downward. No? And also, katulad yung Corvette na sinasabi ko, yung makina yun nasa likod. Nasa likod. No? To compensate with the downward force which is happening on the hood. Okay? So, yeah. So that's being used in the automobile also. No? Not only in aerospace, but of course automobile. But of course, it started with the use in aerospace. Okay? Ngayon, ina-adapt na rin nila. All the automobile is being tested in the wind tunnel. Then this is the high-speed wind tunnel. I will just give you a background. No? So ito ngayon yung ito yung compressed tank. So an air will be compressed here. Actually, ginagamit dito hindi natural air, no? Kasi yung natural air, yung expansion niya masyadong maliit. So ginagamit dito usually helium. Okay? Yung helium ngayon, bobombay niya, patataas yung pressure, then i-release. Pag-release niya rito, ito sa throat niya, high pressure tank, no? Then we have the pressure control. Pag-release niyan dito, sandali lang yan. Pag-release niya dito, sandali, tatakbo rin yan. Mag-flow yan, no? Pag-flow niya, pasok roon, ito niya yung supersonic throat. Pag supersonic throat niya, paglabas niya rito, ang taas ng Mach number niya. And this Mach number will produce shockwave dito. Okay? So, kung may wing siya rito, shockwave pa rin kita. So, those are the high speed. No? But of course, itong shockwave formation na, sandali lang yan nakikita kasi mabilis yung andar ng gas. Okay? Until sa time lumabas siya. Pero pinutol na to, siyempre, pabalik pa yan. Sa yung helium, pabalik pa yan doon. Then, babalik yan din sa tangke, bubumbay na naman. Okay? Now, ito ngayon, hindi yan makikita sa naked eye, no? Usually, pag release nito, automatic, meron ditong shutter camera. Sunod yan, halos 1,000 shots siya tayo per seconds eh. Then after that, you will develop. Pag nakita mo siya, pag dinevelop mo, makikita mo yung mga shockwave formation. Eh, kasi kung titignan mo lang, sa sobrang bilis, nakalusot na. Sa sobrang bilis, tapos na, di ba? So yeah, so that is for supersonic wind tunnel. Okay. Illustration lang yan, pero mahabang kwentuhan yan yung supersonic na ito. So ito, this is a typical, no? Alam ko sa NASA to eh. So dito mismo, ang laki ng building, no? Yan yung closed circuit. This is a closed circuit wind tunnel. Okay. Diyan nila inilalagay sa loob, then of course, pinapaandar yan. Then this is for a aircraft. So yung aircraft na yan, pwede mag-tilt yan. And it is being read dito. Pwede rin niya mag-vibrate, binabasa rin ng accelerometer. Maraming ano yan. May mga nakalagay na ano yan. May mga probe na nakakabit. So, all happening, no, pagka nag-vibrate siya o gumagano siya, is being, uh, is all are recorded. No? Nire-record lahat. Okay? So, we have here your shock wave. Okay, this was already, this is what you call the uh, shockwave of the aircraft. No? So, lumalabas na siya, then of course, lumabas na doon. Okay? So, ito siya. Okay, so supersonic na yan, speed of sound, parehas na. Okay? Then of course, dito, supersonic flight. Nasa loob pa rin yung ano, yung aircraft. No? Pagka nakalabas yan, siyempre, supersonic rin yan, more than 1.0 yung Mach number niya. Okay? So, ayan. Ito nga pala sonic boom. Magkakaroon ito na sonic boom. No? Once na na-break na to, kunyari, dito siya, biglang lumabas to ng ano, na-break niya yan, yung sound na to, na-break niya yung sound barrier, magkakaroon ng tinatawag na sonic boom. Para puputok siya, boom! Tapos, yun na, wala na yung ano, kasi mababasag niya kasi yung shockwave. Lulusot siya. So, magkakaroon ng sonic boom. Okay? Then the rest, dito ngayon, katahimikan na dito. So, pag lumabas yung aeroplano rito, lumabas, at supersonic speed, no, like Mach 2.0, wala na siyang marinig kasi yung sound niya nasa likod. Yung sound ng engine nasa likod. May iwan dito yung sound eh. Okay? So pag yan, sobrang bilis na, yung shockwave niya nasa likod, yung sound niya nasa likod. So halos wala siyang marinig. Pag nag-decelerate siya, mamaya marinig niya yung makina niya kasi umabot ulit sa kanya. Okay? Pero pagka mabilis siya, naiwan yung sound doon sa malayo. Okay? So, dire-diretso lang siya. Hindi niya, ano, hindi niya pansin kung umaandar yung engine niya kasi yung sound wala. Okay? Naiwanan eh. This one, this is also a shock wave. Nakita mo, nagmarka siya doon sa water. Okay? At low altitude, ito yan, kita nyo, gumuhit sa ano. So, ibig sabihin, this is a solid, no? Kung ikaw dinaanan ka niyan, posibleng ano ka, o kaya yung glass mo, pagka dinaanan ka, there's a possibility na basagin niya yung glass. Okay? Pagka dumaan. Kaya nga bawal bumasing yan. Di ba? Hindi pa pwedeng babasing yan sa mga bahay. No? Kasi ito yung ano, may tail yan. No? Tapos ito may angle to eh. Ito tawag natin na Mach angle. Binigay na lahat ito. Posisi yan yung tawag na Mach angle. Okay? May Mach angle yan. Okay, so that's it no for today. So next meeting, we will have another. Ganyan lang yan. Then I think, asan ba? May ito yeah. Ang pala yung ano to. Bakit nang multiply ang ganyan? Stop presenting. Doon pala. Okay, so that's it for today. Okay, I think I will check check ko muna. Okay, so for now, that's all. Then, of course, I will meet you next week ulit. Bye-bye.